Whenever a body like your model rocket moves through the air exerts a retarding force on the body called aerodynamic drag. Aerodynamic drag results from collisions of billions of air molecules with the surface of the body as it moves through the air. In each of these collisions, the air molecules transfer some of their momentum to the body. The sum of all these collisions and minuscule momentum transfers is a net drag force on the body which acts opposite the direction of its motion. On your model rocket, drag will tend to reduce the maximum speed and maximum altitude that it can attain. Therefore, you should attempt to minimize the drag on your model to maximize its performance. To do this, you need to understand a little bit more about how drag is created. When your model rocket moves through the air molecules have the strongest collisions with and transfer the most momentum to the rocket's nose and to any other forward-facing surfaces of the rocket. The sides of even the most carefully painted and highly polished model rocket body are still rough on a molecular level. So as the air molecules flow along the body, they have collisions with and transfer momentum to the tiny hills and valleys of the molecularly rough rocket body. When the air molecules reach the rear of the model rocket, they have lost much of their momentum. Many of the molecules can't make the sharp corner at the rear of the rocket and so separate from the rocket body at this point and trail straight back with the airflow. Those molecules that do make the corner have very little momentum left. Their collisions with the rear of the rocket are relatively weak and transfer relatively little momentum. This rate of momentum transfer due to air molecule collisions is felt as air pressure. The region of low momentum transfer and therefore low pressure at the rear of the rocket is called the rocket's wake. The net drag force resulting from high pressure at the front of the rocket and low pressure at the rear of the rocket is known as pressure drag. You can minimize pressure drag by minimizing the diameter of your rocket's body tube and the size of any other forward-facing parts. The drag which results from air molecules flowing along the surface of the body is called skin friction drag. You can minimize your rocket's skin friction drag by keeping its surface as smooth as possible. We use a model of a recreational vehicle in the wind tunnel to simulate a rocket that was launched with no nose cone. Notice how the air that strikes the front of the body then tries to flow around it and separates at the sharp corners at the front edges. This produces a wake which is much wider than that of the rocket body. This squared off shape therefore has much more pressure drag than the rocket body shape. You can minimize the size of the wake and therefore the pressure drag on your rocket's fins by sanding the fins to give them a round leading edge and a sharp trailing edge. Because your rocket's fins will produce a larger wake and therefore more pressure drag if they are at an angle to the airflow, you can reduce pressure drag on the fins by gluing them on correctly aligned with the rocket body. You know from other videos in this lesson that having your rocket's fins at an angle to the airflow causes them to generate lift, which will cause your rocket to possibly spin or veer off course. That's another good reason to make sure your rocket's fins are properly aligned when you glue them on.